Okay, let's just dive right into this. Welcome, everyone, to today's Explainer. We are going to be unpacking a really fascinating chapter today, and it focuses entirely on something called spatial awareness. Now, I know that might sound like a highly technical academic term, but it's actually the secret code to how we navigate the world every single day. Seriously, whether you're trying to figure out if your car is actually going to fit into that tiny parking spot, or you're just trying to read a confusing mall directory to find the food court, you are using spatial reasoning. So today, we're going to explain this chapter by zooming all the way in on how we view simple, everyday objects from completely different angles. And then we'll slowly zoom out to show how those exact same principles let us navigate massive, real-world spaces. Basically, we're going to train our brains to see the world completely differently. So here's the roadmap for our explainer today. First up, the power of perspective. Next, we're playing the grid game. And finally, mapping your world. All right, let's jump into section 1, the power of perspective, seeing things differently. Now, what's really interesting about this chapter is the core idea. It's simple, but honestly pretty profound. Your physical location completely dictates the visual information you receive. Literally, if you change where you stand, you change what you see. Let's look at how this plays out in a super simple game of hide and seek. Here we've got Jagit, Minnie, Bolu, and Ronnie. Most of the kids are down there on the ground level, right? They're navigating the trees, peeking around the sides of the house. But notice Ronnie up there on the right. She actually climbed up onto the sloping roof of the hut. By doing this, she hasn't just moved higher up, she has essentially unlocked a completely different visual data set of the whole playing field. So this brings us to a really great question to test our spatial logic. If Ronnie, standing way up there on the roof, turns and faces towards the hut itself, will she be able to see who all are hiding near it? I want you to mentally trace her line of sight for a second. Imagine looking from the top of that roof, angling straight down toward the base of the walls. Because of her elevated, top-down perspective, the walls of the hut don't actually block her vision the way they would if she was down in the dirt with everyone else. She can see right over the obstacles. I mean, that is the ultimate strategic advantage in hide and seek for sure, but it also perfectly proves how your perspective entirely dictates your awareness. Let's look at another example from the chapter, this time with just a single object. Here we have two drawings of the exact same brick. Minnie's drawing shows the brick from an angle, so you can see the height, the side, and a little bit of the top. It looks like a proper three-dimensional block, right? But Ronnie is looking at that exact same brick straight down from above, so her drawing just looks like a flat rectangle with the numbers 7777 stamped inside. Honestly, if you didn't know any better, you'd probably think they drew completely different objects. But they didn't. They just captured different visual realities based purely on where they were sitting. And this brilliantly illustrates the exact same phenomenon, but with something found out in nature. In the source material, the character Bolu was just totally amazed by this. We have the front view of a tree, the classic shape we all draw with a brown trunk and green leaves on top. But then we have the top view of that very same tree. If you were a bird flying over it or looking down from an airplane, you wouldn't see the trunk at all, would you? You'd just see this textured, green, kind of cloud-like circle. It's a really great reminder that our brain's default image of an object is usually just its front view, but actually, that's only a tiny fraction of the object's reality. So the absolutely crucial takeaway here is that we can formalize these different visual realities into specific terms. We have the top view, the front view, and the side view. Now, these aren't just fancy art terms. They are literally the fundamental building blocks of spatial geometry and architecture. They describe the different visual shapes an object takes depending strictly on the observer's physical position relative to it. Mastering this chapter means really understanding that getting a true picture of reality requires us to look at things from multiple angles. All right, moving right along to section 2, playing the grid game, finding your place. Now that we've totally mastered viewing single objects, let's zoom out a bit. How do we define where an object actually is in a larger, flat space? Well, we use a grid. Navigating a grid is essentially just a very simple 3-step dance. Step 1, you find the row, which always runs horizontally, left to right. Step 2, you find the column, which runs vertically, up and down. And step 3, you just trace those two lines until they cross, and boom, you locate the intersection. That specific intersection is the unique address for whatever object you're looking for. It's a brilliant system, really, because it completely removes all the guesswork and gives you a precise mathematical location for anything. Let's actually play this out with Bolu's grid from the chapter. Imagine we're getting clues to place objects. The first clue is, draw the ball at the bottom left corner in the first row and first column.
Okay, so we look at the horizontal row 1 down at the bottom, follow it over to vertical column 1 on the far left, and there is our ball. The next clue is to place a water bottle in the third row and second column. Go ahead and mentally trace that with me. Up to the top horizontal row 3 and over to the middle vertical column 2. And there's the water bottle. By just combining horizontal and vertical data, we can instantly pinpoint absolutely any location.
Which brings us to section 3, mapping your world, navigating the big picture. Okay, now for the grand finale. We are zooming out to the widest perspective possible. We're going to take everything we just learned about top-down views and grid intersections and apply it to a massive, complex space, a map. The chapter presents us with a really practical scenario, which we are calling the delivery challenge. We need to help a water delivery man navigate this bustling school campus map. He's starting down at the entrance, and his ultimate destination is the MDM kitchen. To do this, we have to look at the map from a top-down perspective, almost exactly like Ronnie up on the roof, to guide him through these pathways. So, let's walk through his route together. He starts at the entrance. The directions tell him to turn left immediately. As he walks down that path, he goes right past the primary wing building on his right side. He continues straight and finally arrives directly at the MDM kitchen. See that? We used a top-down map to give actual ground-level directions. Now, the chapter also throws in this really great bonus challenge, finding a route from the grade 4 classroom all the way over to the stage. Now, you know as well as I do, if you look at a map, there are usually a dozen different ways to get somewhere. But finding the shortest route, that's where it gets fun. That requires you to visually calculate the distance of straight lines versus the extra distance you'd add by taking turns around buildings like the middle wing or the library. It's like a giant puzzle where you're synthesizing everything we've learned about spatial awareness into one complex decision. And that, my friends, brings us to the end of our explainer today. But before you go, I want to leave you with a quick thought experiment to try the moment this finishes. Just take a second and look around the room you're sitting in right now. You are currently seeing it from the front view, from your specific, grounded perspective. But if you were a bird, floating directly below the ceiling looking straight down, what would the top view of your room actually look like? Where would the rectangles of the tables be, the squares of the chairs? Practice shifting your perspective like that, and you'll quickly realize the world is so much more multidimensional than it appears at first glance. Keep exploring, keep questioning your viewpoint, and I'll see you in the next explainer.